So let's dig into generics. Generics parameterize types in the same way that functions parameterize values. So we're going to talk about when it's appropriate to use a generic, the ins and outs of type parameters in general, and how to constrain type parameters so that both, like for example, within a function, you have what you need in order to have type safety within the function, and the outside world is happy with things as well. Because types are just constraints, and they represent contracts between various entities. So we're going to look at the notes for section 5. As I said, generics parameterize types like functions parameterize values. For example, if we had a function like this, and let's pretend it's just written in JavaScript, right, with no type annotation. This function produces a wrapped value, and depending on what we feed it, what we give it for x, that will determine the value of the thing that comes out, right? We can put whatever we want there, and the function allows us to reuse this piece of code whether we want to wrap a string or a number or have a wrapped value inside a wrapped value. The parameter x is sort of a placeholder that is used, and it allows us to reuse this piece of code. Similarly, we can create a type that allows us to provide a type parameter, in this case x, in between these angle brackets. And that type parameter will be used as the type for this property value. So here's an example. If I pass in string array, this is just like passing an argument to a function, right? But I'm passing a type to a generic type. So because of the tooltips, like this is correct, but I'm more interested in what I can do with this thing. If we look at val.value, we can see that it is a string array, which you can see right over here. If we were to change this and make it just a string, well, we would get a type error here. We'd have to make this a string. And now the type of value is string. Sorry, it keeps disappearing. I'm being overzealous with my mouse. But hopefully you can see here, we're sort of filling in a blank. We're providing a type that is then incorporated into what wrapped value shakes out to be. So you can name these type parameters whatever you want. I can make this, damn function keys. You can make it front-end masters, just like you can name function params whatever you want. That's completely a local name to everything that has access to this type param, which is just sort of, think of it like the same idea as a closure, right? You have a scope, and this is a local variable. It's almost like an argument passed to a function. The name of that argument only has meaning within that function. So the convention, which you'll see a lot, is to start with the capital letter T and use capital letters like TU, V, or S, or R. This is a carryover from C++, which uses template parameters, which basically, like, they're conceptually identical to this. So that's why you'll see a lot of TypeScript code, including my examples, that just use like the capital letter T. But that's just like saying this function takes X and Y as arguments, and we could name this whatever we want. So if we were using something like array filter, we could type a function that would appropriately filter based on the types of things that might be in this array, right? Like if we were filtering through an array of strings so that we could remove any empty string we found, we'd want to accept as our filtering function, we want that to take a string as an argument and to return a Boolean. And in fact, that is what happens. If we had like an array containing strings, dot filter, and we start to implement our callback, let's say it's a filter that always passes. Turns out x has a value of a string. Right? That's just what we want. If we had a named function that was designed to a named function like this that only wanted to receive numbers, we would absolutely want this to say, there's a misalignment here. Your function's designed to take numbers. I need one that's designed to take strings. So this would be an appropriate type using a generic that would allow us to sort of fill in the blank. What is the type of the entity you're filtering for? So here's an example of us using this generic type, passing in string as the type parameter. So this t will turn into a string. And we can see that now val is a string, and we're checking to see if the type of val is a string. This all looks great to me, right? The runtime stuff, that runtime stuff looks exactly like what I would want to check if there's a string or not, and this, in fact, should be a string. If we try to pass in the wrong argument, obviously we get an error. Otherwise, if it's the right type, we get OK. We also have here something like this syntax here. So I've been likening type parameters to function arguments. Based on that analogy, can someone venture a guess as to what equals any means in this context?
You don't pass supplements in any.
What's that?
The default value is in any.
Correct. If no type parameter is provided, we fall back to an any. That is the default of this type parameter. So here, if we hover over this, this ends up being an any, and this is sort of a filter just for truthy values, right? It sort of passes x straight through, passes val straight through. And as a result, this is what you could expect. You'll get no type errors for passing an argument to this, because anything goes, right? So it's the equivalent of a default parameter value. It's just a default type. So far in our examples, like in this example, we've declared that we have this type parameter t, and we have found that we're using t directly. But you don't always have to do that. You're not limited to that. Here's an example, a little bit more complicated, but one that I have pulled out of my own code, that when passed a promise, and this is the promise type is generic over the type that it resolves to. And when we say generic over, that means that it abstracts the type that it resolves to. It takes it as a type parameter. So you could have a promise that resolves to a number, or a promise that resolves to an HTTP response. Right? That's what you get back when you call fetch. So t is the parameter, but I take as an argument promise t. And I'll infer what t must be based on the promise that I'm given and its type. So it takes a promise as an argument, and it takes a number as an argument, and it'll return a new promise that'll either time out if time's up, or if the promise resolves before the time's up, it'll actually pass through the resolved value of that promise. And here's the implementation. Should hopefully make sense. We call set timeout. This thing that set timeout returns is necessary in order to cancel the timeout later on. And it's all set up, if nothing else happens, to reject the promise. If the promise resolves, we cancel the timeout. We don't, it's not finished. It may never, the callback that we pass to set timeout may never get invoked. And then we resolve with the value. Note that I don't have to pass in anything with angle brackets here. And the reason is fetch returns a promise that resolves to a response. And so through receiving this as an argument, TypeScript figures out that t must be a response. It infers what t is by kind of plucking it out of the promise, or the type of the promise. Type parameters can also have constraints. So one thing that as you start using type parameters, you'll see that if you don't have a constraint like this, and this is the constraint part, this is saying T must extend, must be assignable to this type here. The best way I can explain constraints to you is to remove this to reveal the motivation for adding it. And there you go. So we're getting a type error because we're trying to transform an array of type T to a dictionary of type T. And we begin by creating an empty dictionary. We iterate over the array. We try to place each value into the dictionary. But it turns out we can't access this property ID off of each member of our array. And the reason is we have not declared that there's a minimum requirement that T must meet. And as a result, there's very little that we can do with values of type T inside the function. It's really flexible in terms of what can be passed into the function, but you can only do the things that you've explicitly asked for. If we need to access ID, we must state that T must be an object and it must have a property called ID. And this is how we would do it. We accept a type T that is at least an object with a property ID whose value is a string. And now this will be a string. So this is the equivalent of doing something like this. In fact, we could try to remove this and just say, I'm taking an array of objects that look like this. And we could try to change this. Right? Instead of T there, we could replace the T here. We're going to run into another problem. So I've basically boiled this down to my minimum requirements. I've said, transform this array to a dictionary, but there's no type parameter anymore. Here's the problem we'll run into. Number one, we're getting errors for passing in any properties that are more than simply having an ID whose value is a string. The other problem we'll get is when we try to access things off of it, we've greatly simplified this type in a bad way, right? We've lost any of this extra stuff that was passed in. What we want is to be able to pass in anything that has an ID that's a string, and to get out a rearrangement of this from an array to a dictionary. But we haven't lost any fidelity in the types. We still have access to everything we put in. And that's where we're going to say, all right, whatever you give me, an array of type T, I'm going to give you a dictionary of type T out, right? You'll still be working with whatever you pass in. You'll still get it back in dictionary form. I'm not going to reduce it down to just objects that have ID. You'll have it as you gave it to me. And then the type constraint we already went over. This is the equivalent of saying, look, I'm not just going to take, it's a way of stating your requirements for working with this type within the function. And why isn't everything happy? I forgot one last thing. Now we're good. So just to recap, by making this abstract, by adding this idea of a generic, we can retain the detail of the object we passed in, even though this function that was doing the work, it knows nothing about these extra properties that might be there. But because it's given us a blank that we can fill in, from the outside we can say, for the purposes of invoking this function right now, I'm giving you, huge objects with lots of properties and an ID, and you'll get those same types back. You won't have to deal with sort of the lowest common denominator, because that puts you in a position where you sort of have to figure out a way to widen your types again to make things more useful. Like function arguments, type parameters are associated with a scope. So here we have a function that returns a function. Start tuple, finish tuple, right? And we're using a technique that Kyle Simpson in his front-end master's course on functional light programming. He calls this zero-point programming because we're returning a function and then invoking the function that it returns immediately. So we pass in one argument, an array of strings, a second argument, a number, and the type of the tuple we get out is this. So just like A and B, right, the values, those are regular function parameters, in here we can access both A and B. And because of this analogy where like generics are like functions, we can also access U and T. Now out here on line 94, could we access B? No. And we can't access U either. They're associated with scopes in the same way. And this fits similarly to having like a type parameter on a class and then on a method within that class, right? Outer and inner scope. You could have like a class, a method within the class, a function that returns, works just as you'd expect. I've found this to be a very effective analogy. So the last thing we're going to tackle here is when to use generics. It's a really, really powerful idea, but people who run into trouble with types that begin to explode in complexity, often that comes from overzealous use of generics. And I would also be careful reading blog articles and question the information that you see out there, because this is one thing that a lot of content gets wrong. I'm going to show you a bad example here. So we've got an interface called shape. It has a method on it called draw. Circle extends from shape. Circle has a radius. So here we're saying draw shapes. And we have a type parameter where S must extend shape, and we take in an array of S's, and we iterate over each of those and draw. Here is another implementation that just uses a base class here. So generics are great for relating two things. I take in an array of T, and I give you back a dictionary of T. The generic, that type parameter, is what ties those two together. You give me strings, I give you back strings, right? Here, we're only using this type parameter once, and you can always eliminate a type parameter that's used once. There's a convention that people like to use where I don't disagree with it as much, where they'll, for convenience, use a generic for a type assertion. For example, they'll wrap fetch in a function and allow you to pass a type parameter indicating the structure of the response. Okay, I mean, you could certainly eliminate it, right? But there is some convenience factor there. This kind of thing that you're looking at in front of you, there is no convenience here. This is just unnecessary abstraction. But what this does show us, it is useful for one thing. It does show us that specifying this type here, like that's what allows us to access this method draw. This gets us the same thing as this. So constraints on type parameters are equivalent to specifying the type on an argument, in that it dictates what you can do within the function on S, right? In both cases, we've got .draw, right? Up here it's coming from this, down here it's coming from that. Yes?
So on line 121, if shape was not an interface and it was a type alias, would it not work?
It will be fine, I think. Type shape equals this. Yep, no problem. This is we're in the very large amount of overlap where there's no real downside to choosing one or the other.
Sure. Well, I guess I'm just confused on why on line 121, if you're passing in shapes and they have radius, wouldn't that error because it's just expecting something with only draw?
Can you articulate why you would expect it to error so I can answer that question?
Well, yeah, because so the interface, like, something implements an interface, but it could have other attributes.
Totally.
With a type alias, isn't that like a strict definition? Like, it has to have this stuff, and if you pass a circle in to draw shapes 2, and you're only telling it, I want a shape, wouldn't it also expect a radius?
If I was demanding circle here, yeah, it would. I would say this is an overly. This is asking for too much, in that I don't need radius down here. I have access to radius now. If I needed this, I would demand circles. I would say, you got to pass me circles. The rule I like to follow is you ask for only what you need and you return everything you can. So you ask for only what you need so that you can use this with square and triangle and 2D point, which is just going to have an X and Y. You want, like, if that's going to work, if it's all up to the draw function and you need no further details, this is your minimum requirement, and you can stick with that. Now, on the other hand, if you're returning something, you want your consumers to be able to access all of the richness of this object to whatever degree is safe. So if, let's say we had multiple types of collections, like a list, an array which extends list, a linked list. Like, if array and linked list have special methods on them, there's no reason for me to kind of give you back a very low-level base class. That would prevent you from safely accessing the rich functionality underneath. So ask for only what you need, return everything you can. Yes, sir.
So the two functions are equivalent then? But you're saying the top one is just overkill on the generic?
They're equivalent, and they will compile to exactly the same thing, aside from the name of the function.
Could you give an example where you would actually want to do the?
Absolutely. How about this? Let me think for a moment. An example where the type parameter would be necessary.
Where you'd actually want to use the generic.
Yep. Okay, here we go. So I'd have to involve something else. Sorry, that's not true. That's Boolean. I'd have to introduce a second use of this type parameter. Like, for example, return an array of these things. And I'd say map and S is drawn true, return S. So now, let's see, why is this unhappy? Thank you. Okay, so now the fact that I'm using this in two places, this serves a purpose. Without this, even if I just were to say it return shape, we have a significant downside in that if I were to try to say draw shapes 1 and pass an array of circles, so there's my circle. What don't you like there? Radius is a number. Like, I'm already getting into, I'd have to be explicit about this. Like, it already is saying this is an unknown property on shape. I could create this outside. And now it'll be happy. But now I'm in a situation where if I wanted to chain off of that, I have reduced this down to an array of shapes. I don't have an array of circles anymore. I didn't get out what I passed in. I got out the lowest common thing that the function needed. Whereas if we return an array of S's, now radius is present.
If you pass in circles, you're going to get circles back. If you pass in squares, you get squares back.
And you can see it right in the tooltip. See how like all of the S's have changed to circle? The blank has been filled in at this call site. And this is where a type param would get you something, in that draw shapes does not care about the particulars of the shape, but what it will do is give you back what you passed in. Or I could return like a promise that resolves to S or something. But the key is I've introduced a second use of the type parameter, and that makes this generic worthwhile. Now the type parameter is describing a relationship between arguments and return. And like for classes, you could say, I take in this in my constructor, and that method returns this type. There are many more opportunities with classes because you have so many different parts to them, right? But you've got to be able to point to two. If you can't do that, you may just be using a type parameter as sort of an assertion, right? Where you're saying, like, give this back to me as a string. Give this back to me as an array. But that's not the same thing. That's not what type parameters are typically used for. So we're going to create some familiar looking utilities built around a dictionary type. Has anyone here used map and reduce on arrays? Show hands. Awesome, everybody. So we're going to build map and reduce for dictionaries, and we're going to define a dictionary type. So here's an example. We have a file extensions dictionary on the right. We would say this is a dictionary of string arrays, and we want to iterate over the values. If we're talking about mapping, we want to produce a dictionary with the same keys, but with transformed values. So we would get something like what we see in the bottom right. So maybe we're building like a open file dialog where we want to list all of the extensions. And like looks like JPEGs and HTML files have multiple extensions that are valid. And we're going to use our knowledge of type parameters so that this should work neatly with an arbitrary dictionary, where we can operate on things that have types that we don't know the details about, but using type parameters, we can still abstract all of that away, operate on these data structures, and give our consumers back the high fidelity types that they can then carry on and use. So this is in the challenges/dict folder. So the first thing I want us to think about is defining a dictionary. So can someone help me flesh this out? I know this is not a dictionary. Help me create a dictionary that uses a type parameter. So I could make a dictionary of numbers or strings or string arrays. What would I need to change here? So we've just been talking about generics and type parameters. I probably need something up here. What makes a dictionary a dictionary? How is it different from an array?
All of the values are the same type?
All of the values are of the same type. So we're going to have something and then T. Oop. And how are the values organized within a dictionary?
Key value pairs?
Key value pairs. And how do we type an arbitrary key access in TypeScript, where I can pass in home or office or iPhone and get a phone number back?
So you have that array where K, colon, and then the type.
Perfectly described.
Is the K special in any way, or can that be anything?
It can be whatever we want.
Is that convention?
So I call it K because of key. It's the equivalent of naming a function argument. And this is just the type that goes with it. There we go. And I'm going to follow the convention of acknowledging that if I pass in a key, I might get nothing back. How would I add that to this type?
Or undefined?
Question mark.
Good. Actually, we got two good answers. So I can't, I can do it this way, and I'm going to go out on a limb here. Oops. Yep, looks like the optional is not going to work. That's a very good guess, though. That we, like, I would expect that to be something they'd introduce in the future. There's really nothing stopping them. In fact, I don't want to get too deep into more advanced things here. There is a way that you could specify it with the question mark, but you're both right in that either will introduce the possibility of the value being undefined. Great. So according to the use of these things, if these are going to be like freestanding functions, the first thing we're going to pass in is a dictionary. So we're going to make it a dict t. And it's saying cannot find name t. Anyone have an idea of what's missing here? A constraint? I don't think we need a constraint right now.
Function
T
has
is-
generic T.
Function should have a generic t, right? We have to state kind of up front that this function, like t is not a reference to an interface called t. There is a type parameter that this function uses, and it is called t. Great. And I'm going to add the mapping function here. So conceptually, when we use array.map, how would you describe the function that we pass in? What's its purpose?
To loop through whatever array you have.
Sure, we iteratively invoke that function. And what does the function do?
Transforming it.
It transforms it, potentially from one type to another type, right? So in this case, we should probably take an argument of t, because we're iterating over a data structure that has values of t, and we're spitting out something else. I'm going to introduce another type parameter, because that's what we're transforming to, and I'll fill in the function in a second, but we're going to return a dictionary of these transformed values. Now all that's left is for us to define the function itself. Arg is a t, and it returns an s.
Can you ignore the index argument?
Can I ignore the index argument?
A second argument in a map function?
You could. It wouldn't, like in terms of using array.map, that would sort of defeat the purpose. The function is the definition of the work to be done. We could make it optional and then just return the same dictionary again, but to me that would be a sign of misuse, right? It's like all we could do is iterate over the array and do nothing, right? So without instructions as to how to transform from one type to another, I would say there's no point in this. So I would keep it mandatory in this case.
Oh, I mean like for the function type arg is t, but then as a second argument of that function is an index of type number.
Sorry, thank you. Absolutely. Yeah, we could totally do that. And we don't need to make it optional, because the way that the type equivalence works, if a function chooses to not receive that argument, that's fine. If we made it optional, we're indicating that we may be providing it, but it could come through as undefined, which is not what's likely to happen. So let's implement this. Conveniently, it's easy to create an empty dictionary, right? We're going to create an empty dictionary. We're going to loop over the existing dictionary and populate the thing that we're going to return, and then we'll return it. So there you go. That's the easy part. And now, how do we iterate over an object's keys?
Object.keys.
Good. Object.keys, dict And I'll just use for each. And this receives a value and an index. That'll be useful to pass along. And we'll say we're going to place in the output dictionary under the, sorry, this is not, I want to rename this for clarity. Under the same dictionary key, what do we do next? Got to use that function, right? I'm almost done and I haven't used it yet. So this function is made to take in a t and an index and return s. Dict and dkey. Great, thank you. And this is of type T or undefined, right? Because, like, in theory, there could be something missing in this dictionary. There could be someone who's deliberately placed an undefined value in there, trolling us. If this item, and we'll return, sorry, not return, we'll only place the output item in this dictionary if it's defined. Oh, I got to be careful here. I just realized, like, what about zeros and empty strings and other falsy things? There we go. That's more thorough, right? So we're looping over all of the keys in the dictionary. We're grabbing each value, if it's defined, transform it, pass along that, like transform it using this function by passing along the original value and the index. We get the transform value out, and now we return this thing. This is a place where we can point to the places we're using the type parameters, and it's quite necessary, right? So we take in a dictionary of type T. T helps us type the function we're using to transform. And the function we receive returns something, and that's how we'll be able to infer what S should be, and that determines our output type. So check out how I can use this. Map dict. Do I have one already created? Nope. So we'll create just strings. And I'll have a function here that'll take the string as an argument. And if I return an array of strings, mapDict will return a dictionary of string arrays. If I were to wrap it in an object like this, it's arrow functions regarding that as a function body. Now it's a dictionary of sort of wrapped values. Notice I had to use type parameters to define what this thing does, but where I'm calling it, this looks relatively simple. The types kind of just work. The blanks are filled in, and they're inferred by the arguments that I'm passing to this function. They don't have to be explicitly specified. So this would be a well-chosen use of generics in that it's a really flexible piece of code. The types that it returns, like you have as much level of specificity and detail that you need in order to carry them forward, and I don't have to provide anything explicit. We'll make sure that the solution to the reduce exercise here will be in the repo, and it follows a similar pattern.